Hey there, we're going to continue where Miss Garcia left off. We're going to do some more of the same, just with some little twists. So let me just say this, these videos are probably going to be long, so you guys decide where you want to take a brain break. Like when we naturally shift from one topic to another, just like if you need a brain break, turn the video off, go take a break, and then come back and finish it later. Okay. All right, so for these first two problems, we're going to evaluate the function at each specified value of the independent variable and simplify. So we're presented with g of y equals 7 minus 3y. So I know you're used to f and x, but we got to get used to other letters of the alphabet. There's 26 letters in the alphabet. We can't always just use f and x. So g is a function of y is the independent variable, g is the dependent variable. This input value just tells you, hey, look out, you might see a y in the equation, and we do. All right, part A, g of 0. So our input value, our independent value is 0, so wherever y is, we replace it with 0. So the correct notation would be g of 0 equals, and I'm referring back up here to this equation, 7 minus 3 times 0. You can either use the multiplication dot or you can use the parentheses for implied multiplication. So g of 0 equals, keep bringing this down. This product using PEMDAS, order of operations, is 0, so my final answer is 7. We're technically done, but let's talk notation. This is function notation. This kind of reveals to us that we're working with the g graph or a g equation. The input value is 0, the output value is 7. So another way to think about it is that the ordered pair 0, 7, okay, is on the graph of the g function. I prefer function notation just because it's more revealing as to what equation we're using, and we're using g. When you just look at the ordered pair, you really don't know, are we working with an f, g, h, what function are we working with? So for me, both these answers are correct. I just like the function notation better. All right, g of 7/3, so we're still using the same equation. Let's write down the notation. Look back at the equation, 7 minus 3 times 7/3. You can use multiplication, I just like the parentheses here. All right, following order of operations, let's multiply these two numbers together. You can put 3 over 1, and then instead of just multiplying the tops and the bottoms together, let's look and see diagonally or either straight up and down if I have a common factor. So I'm going to divide out a 3 here and divide out a 3 here. So we have the remaining 7 here, 7 minus, and then this product is 7. So I like this answer, but just know that you can write this as 7/3, 0. That's the ordered pair or the point that's on the graph of this g function. So I think it's good practice to maybe write the notation both ways. All right, let's look at part C. So we're still working with the g function. We have a g function here, but now our input, whatever we put in for y, is going to be replaced with k plus 5. Kind of weird, isn't it? But the structure helps us know what to do. Let's not get caught up in it too much. So I know that all of k plus 5 is going to be input for the y. So, but back to the equation, I have 7 minus 3 times, and this is where y is, but now we're going to put k plus 5. So we need to distribute the negative 3 through here, so I'm going to have 7 minus 3k minus 15. We have a little cleanup to do, don't we? So taking care of the numbers, 7 minus 15 is negative 8, and then minus 3k. So this is function notation. You can write this as an ordered pair also. Your input is k plus 5, comma, and your answer, your output, negative 8 minus 3k. All right, let's look at number 2. I would suggest turning the video off, practicing, seeing what you guys can come up with, then turning back on the video and seeing what the answers are. I think self-assessing is a good learning strategy. Take a risk. If you make a mistake, who cares? We'll go back and fix it. So now on number 2, we're working with v of r. So it just tells us, hey, look out, there's probably an r variable in the equation, and there is. So V of 2. 2 goes in for R, which means 2 goes in for all R's, and 2 goes in here. All right, so let's clean this up a little bit. Let's do order of operations, the power here. That's going to be 8. I might go ahead and put pi over 1. Since I'm multiplying and 4/3 is a fraction, I might as well make pi a fraction. And then 2 cubed is 8. I might as well go ahead and put 8 over 1. All right, I'm going to look across this multiplication problem. I'm going to look at the 3, and I'm going to look at the 8 and the 4. I don't have a common factor, so all I can do to clean this up is multiply all the numerators together. So 4 times 8 is 32, and put the pi behind it. That's kind of common practice, all over 3. I'm just going to go ahead and leave my answer as this function notation. You could write the ordered pair 2 comma 32 pi over 3, but I'm just going to leave it like this, and so can you. All right, so 4/3 pi, R is 2/3. Our input value is whatever's in between the parentheses, and we have to cube it. All right, let's see how we're going to manage this. I see I'm going to have to cube this fraction first. I'm going to go ahead and put the pi on top with the 4. It doesn't go in the denominator. So I'll just make this 4 pi over 3 times, and I'm ready for a fraction to be placed here once I cube 2/3. So in a fraction, when you take it to a power, let's